Hi there. In today's video we're going to talk about how we name and write formula for ionic compounds. As a quick reminder, ionic compounds usually form between metals and non-metals, and ionic compounds are formed when ions, charged particles, charged atoms, they either become cations when they lose electrons, so they become positively charged, or they become anions, these negatively charged atoms, because they've gained electrons. This gives those atoms overall charges, positive or negative, and it's those forces that join together to make these ionic compounds. So how do we name ionic compounds? Two-step process. The first part of the name is the cation. So the first part of the name is the cation, usually the metal. So let's take, I don't know, sodium. Let's take sodium and we're going to add it to chlorine. So sodium is our metal. It forms a positive ion. So sodium, so e.g. sodium. So let's combine sodium. The second part of the name, non-metal, or the anion. So this is the anion. And what we do to that is we add IDE onto the end. So we add IDE onto the end of it. So if we're joining, let's say example, let's go chlorine. So chlorine becomes, instead of chlorine, we add IDE, so it becomes chloride. Okay, chloride. So sodium and chlorine makes sodium chloride. Let's do another example. Let's take lithium and oxygen. So let's combine lithium and oxygen. Well, the first part of our name, so this is going to become our ionic compound. So lithium is our metal, so the cation forms a positive ion. So our first part of our name is lithium. And the second part of our name is the anion, which is oxygen, but we add IDE onto the end, so it becomes oxide, lithium oxide. Oxygenide doesn't sound right, so lithium oxide is the correct way of doing that. So that's naming compounds. A couple of exceptions to this. IDE is when we use these things called polyatomic ions. I'll talk about that now. Or radicals, okay? Or radical. But we're going to call them polyatomic. Now polyatomic means many, so this means many, and this means polyatomic atom. Let's change colour. Atoms. So polyatomic ions are groups of atoms that are positively or negatively charged. So polyatomic ions are. So some examples of them would be hydroxide, which is OH, and they're -1, so they act together. So these tend to stay together during chemical reactions. Another good example is nitrate, that's NO3 minus, so that's also negatively charged. And I'll give you one more example. What should we say? Let's say carbonate, that's CO3, and this time this is 2 negative. So these different polyatomic ions are charged. Okay, there is one positive example, and that's ammonium, which is NH4, and that's positively charged. Okay, so that would act as the cation in a reaction. These are all anions because they are negatively, but these are polyatomic ions. Here's a table of common ones that you're going to be using, and we'll provide this in the exams and questions this year, but next year you need to learn them. So it might be a good idea to start learning these polyatomic ions now. Alright, let's move on to writing formulae. We've learned over the course of this unit that compounds have a set ratio of atoms in them. So water is always H2O, it's always got 2 hydrogens and 1 oxygen. we mentioned when we were naming just a minute ago, sodium chloride and lithium oxide. So we know they're compounds, but how do we know the ratio of atoms in those compounds? Well, we can work that out, and we can use our periodic table to do that. All right, let's go through how to write formula. So first step is we need to write the symbols. So let's take an example. Let's take magnesium chloride. Let's take magnesium chloride. So the first step, is we write symbols. So first step we write the symbols. So magnesium and chloride. So we have magnesium and we have chloride. So yeah, magnesium and chlorine. Step 2, we write the charges. So magnesium forms 2 plus ions. It's in group 2, has 2 valence electrons, so it's going to lose those, so it becomes 2 positive. Chlorine is in group 7, 7 valence electrons. It's going to gain 1 electron to have a full outer shell of 8, so it's negative 1. So we can write 1 there if we want, or we can just have negative. Let's say negative 1 negative. Right. Number 3, we cross over the charges from top to bottom. From top to bottom. So let's take our magnesium and our chlorine. So we swap the charges over from top to bottom. So this 2 plus goes down here, and this 1 minus comes down there. So fourth step, we remove the charges. Now we've got Mg1 and Cl2. Final step is we simplify and remove 1s. So Mg1Cl2 becomes MgCl2. That's as simple as we can make that. So the formula for magnesium chloride is MgCl2. Let's do another example. Alright, so lithium is group 1. Okay, so 1 electron in its outer shell. So we're going to write the symbols. Lithium and oxygen is O. Lithium is +1, as I said. Oxygen, group 6, 6 outer electrons, gains 2, becomes O2 minus. Let's cross over the charges from top to bottom. So that becomes 2 minus. Oxygen, we go plus. We remove the charges. Li2, O. We simplify and remove the 1s. I've removed the 1s already up here. We can't do any more. So lithium oxide becomes Li2O. Let's do an example with a couple of polyatomic ions. Okay, let's look at sodium sulfate. Now when you see the 8, it means there's oxygen in there, and because there's sulfur in there, you can assume it's a polyatomic ion. So you're going to need to use your polyatomic ion table. So the first thing, as usual, with these examples, we're going to write the symbols. So sodium and sulfate is SO4. It's got sulfur and it's got oxygen, so SO4 are the symbols. Now let's write the charges. Sodium, we've done lots, +1. Sulfate, okay, is 2 minus. SO4 has a charge of 2 minus. Same principle, we swap the charges, cross over the charges. So we have sodium, it becomes 2 minus. Sulfate, that has the plus down there. Let's remove the charges. Na2, SO4. We simplify and remove the 1s. Can't simplify that anymore. This acts as one entire thing. So the sodium sulfate formula is that. So there's the formula for sodium sulfate. Do one more example. Write the symbols. magnesium, Mg. Nitrate is a polyatomic ion, and that is NO3. We write the charges. Magnesium 2+, group 2, loses 2 electrons. Nitrate is -1. Cross over the charges from top to bottom. Magnesium, negative down there, then the nitrate, and then we get the 2+ coming down there. This is a little bit different to ones we've done before. Remove the charges. Let's remove the charges before we do anything else. Remove the charges. Mg, NO3, 2. Now that doesn't look right, so we need to do something. Now what we need to do is add brackets around the polyatomic ion, because this 2 means there are going to be 2 of these ions to make up to see where those electrons go. So we put that in brackets. So there's 2 now corresponds to that polyatomic ion. We've simplified it, we've removed the ones already. So there is our formula for magnesium nitrate. That's it. See you again soon. Thank you. Bye.